All right, so welcome back. This is part two of our intro topic one. Now, for homework, you should have tried to fill in the rest of those rating angles. I'd like to draw your attention now to the front cover. It's actually a page into the front cover. There's uh, basically a complete circle with all the radian angles filled in. Now, there's other numbers that are shown on this, but in blue, you'll see those radians. How did you do? Certainly, if you have any questions, what you want to do is reach out, as maybe I would go over how to find any particular one of those remaining angles. Now, sometimes students will say, do I have to memorize all those angles? The answer is no, but you need to know how to find them. And you need to start to understand when you see those radian numbers, what it's talking about. And just simply, it's talking about the amount of radians. Whenever I go like this, I'm referring to that angle you made yesterday. So the amount of these radians that it takes to get to a particular position on the circle. Now, what I'd like to do is build a little bit more when we just into this idea of angles and rotations. What I'm about to show you here is a very simple diagram about rotating. Now, you may have noticed yesterday that I was rotating this way. When you rotate this way, it's known as a positive rotation. Now, be careful. I didn't say that I rotated to a positive place. I'm saying that it's the direction I'm rotating. That's a positive rotation. Well, there's also the ability to rotate this way, which I'm sure you can guess that would be a negative rotation. Okay, now each of these directions could be described as clockwise or counterclockwise. I tend to not use that terminology. I just want you to think about the direction that we went. So if I start going this way, and of course rotate clockwise, that's the last time I'll say that, well, that's actually a negative rotation. But if I rotate this way, it's a positive rotation. Now, let's dig a little deeper into radians. In fact, let's start to talk about how to locate a radian. What I'm really referring to is how to locate like a new radian angle. And so we come up with this kind of question. In what quadrant would you find 4 pi over 7 radians? In what quadrant? Quadrant 1, 2, quadrant 3, or quadrant 4? Now, if you're watching the video, it's another one of those times where you want to pause the video and you want to think about this. You actually want to try it. If you just let the video keep playing and you don't think about it, you're missing out on thinking. Now, if you're saying, but Mr. Nair, I don't know how to do this. Well, there's going to be a lot of times this year where I haven't shown you what to do. I'm trying to get you to think. What did we do yesterday that might enable you to figure out where 4 pi over 7 is? Okay, so even if you feel like you have no idea, stop and think. What might you actually have an idea about? All right, now if we were in the classroom, one of the common responses that I would get from a student would be starting to think of 4 pi over 7, basically, starting to compare 4 pi over 7 to some other known radians. Now, some of the known radians would be 0 radians, pi over 2 radians, pi, and maybe 3 pi over 2. As you can see, this actually divides up into our 4 quadrants. Now, often I'll have a student start talking about the fraction 4/7. They will leave out the pi and they'll just be thinking about like 4/7. And that kind of student is thinking about the fact that this would be a full 1 pi. This would be just half a pi. And of course, we have 0. So the question starts to be, well, where's 4/7? Now, if you know your fractions, you know that 4/7 is actually just a little bit bigger than a half. This is a half of pi. So if I have 4/7 of pi, I'm a little bit more than a half. But of course, I'm not the whole way to 1 pi. So if I have 4/7 of pi, I'm going to be somewhere around here. Now, we do call it 4 pi over 7, but we're kind of thinking about the idea of 4/7. Now, another way that I'll have students start to process this is also by thinking about the full decimal, not just kind of thinking about 4/7, but rather the full decimal. And the full decimal of 4 pi over 7, I believe, is 1.795. Now, what you want to do is you'd want to compare that. You'd want to compare that to what it means to have pi over 2 radians, which is about 1.57. And of course, to have pi radians is to have 3.14. Okay, now all that's really happening here is we're saying that I've got 1.7 of these radians. That's a little bit more than having 1.5. And of course, it's not having a full 3.14. So we could, by comparing the decimals, say that we're in quadrant 2. Now, just going to kind of generically call that basically like a comparing idea. You're comparing numbers. The other idea, which often I don't get a student to think of this, but it's a great method, is to convert. Now, when you convert, what you're doing is you're actually changing to degrees. But what we need is we need like a ratio. And what I'm going to add to this is that we're going to use the factor label method for our ratio. Now, the factor label method from your science classes tells you to choose your ratio carefully. Whatever you put in the numerator is your end result. So I know that 180 degrees can be compared to pi, which is my ratio, but I'm putting 180 degrees in the numerator because I want to end up with degrees. Now, if you're like, whoa, where'd this come from? Well, that's some knowledge that you'd want to definitely be able to extract from yesterday. To be at 180 degrees is equivalent to pi. So that's our ratio. Sometimes students say, why don't you use 2 pi? Well, just because it's a little bit bloated. 2 pi is to 360 is just going to reduce down to pi is to 180. Now, you put your 4 pi over 7 up here in the numerator so you can cancel the labels. The funny thing is that we really don't write the label. We said yesterday there's really not a label unless you write out the word radian. But just to show you, now I'm able to cancel the radian label, and I'm going to be left with degrees. And it turns out that the pi's by simple fractions will also cancel, which leads us to just one simple calculation, that is finding 4/7 of 180. Now, 4/7 of 180 gives us 102 degrees. And so I think we all know where 102 degrees would be, plus some. But the bottom line is we know that 102 degrees is over here in quadrant 2. And so that's another way that we can start to make sense of radians. Why don't you try one on your own? Okay, giving you some things to think about. Try to take it a step further on your own. Try to find the location of negative 13 pi over 8. I did give you a negative sign. That's why I'm saying we're trying to take it a step further. So take one of the ideas that you've seen up here. Think about negative rotation, where would be negative 13 pi over 8. All right, how did you do? If you got it correct, you'd be in quadrant 1. Of course, I'm not only concerned about you getting it correct, I'm concerned that you know how to do it. Okay, and if you were kind of going on the decimal method, don't be scared of this, is to understand that negative 13 pi over 8 is a number. It's negative 5. Now, what that really means is having negative 5 of those radians from yesterday. But it also means understanding that if you rotate in a negative direction, that it would change my decimal checkpoints to be backwards. So now down here is negative 1.57. Now over here is negative 3.14. Now up here would be negative 4.71. Now if you're saying, where'd you get negative 4.71? Well, I'm converting those four corners, those common radians, to decimals. So 3 pi over 2 is my -4 number, -4.71. All right, and of course over here would be -6.28. Now, if you rotate in a negative direction, you're actually going to be rotating this way all the way till you get to -5. And the idea is that you understand that -5 is obviously between -4.7 and -6.2. How about my students that converted this? I hope that you actually understand both of these methods, quite frankly. So if you convert it, yes, you can always say that 180 is to pi. Okay, that'll always be our base ratio. And then I can just put my -13 pi over 8 in the numerator. Now, if you're saying, do the pi's always cancel? Well, as long as they're both there, they're going to cancel. And so we're really just finding -13/8 of 180. That comes out to -292 degrees. -292 degrees is an angle that's going to be past -270. We want to understand that this is also -270 up here, but of course not the whole way to -360. And so that will also be in quadrant 1. Okay, one more problem. I know this is new, but a radian is just an angle. It's actually a pretty big angle. It's about 57 degrees, right? So where's 5 radians? I actually gave you a little bit of hint in my last comment, but where's 5 radians? Now, it doesn't say 5 pi. It's just 5. So how big is 5? How big is 5? Okay. Often a student would say that if you have 5 radians, that means you're past 1.5 radians, you're past 3 radians, you're past 4 radians, you're at 5 radians. Of course, you're not the whole way to 6 radians, so that's going to put us in quadrant 3. Now, if you're saying, well, how's that different than 5 pi radians? Well, 5 pi radians would be 5 times 3, over 15 radians. It's going to be 3 times as big, but this is just 5 radians, which could be converted to degrees by just saying that you have 5 57ths. And if you have 5 57ths, you have 286 some degrees. And 286 degrees is also down here in quadrant 4. Now, for those of you that converted it with the factor label method, you want to be careful because you only have 5 radians. You don't have a pi to cancel. So you have to do the entire arithmetic. You have to, I would assume, multiply 180 times 5 and then divide that by pi. And again, we'll end up with that same number, 286. Are we starting to get a little more handle on what is a radian? Okay, it's definitely new, but now what you're going to do is you're going to try the regular nightly homework. And I encourage you to use a sampling of these methods. In other words, think about decimals, think about converting, think about both of them so that you can begin to further understand a radian.